Hello, everyone. Can you hear me?
Yes.
Okay. Okay,
Loud and
good.
clear.
Yeah. I received some emails after last lecture. Um, I think two students asking the issue for the Blackboard, they cannot see the syllabus or something. So if you have a same problem, please send me an email. So I think the problem could be they enroll the EE 455. I don't know what's happening to the CS or EE, but I think they're the same class. So yeah, both of the students should, can see the Blackboard. So if you have similar problem, just let me know. And I have already uploaded the slides for the chapter 1 to the Blackboard. I just uploaded. So later I will upload the schedule of the class, the course. For example, when we should finish the chapter 1, chapter 2, and when we will post the assignments. So probably I will upload the schedule today. Okay, but the general idea is that we will teach the lecture, the first chapter of the textbook before the holiday. Okay, I think it's September 7th. So within the first 2 weeks. So if you have any time, you can read the textbook of the chapter 1 and understand some concepts I don't cover. But I think as I mentioned last a lecture, the exam or the assignment will mainly based on my material in the slides. Okay, so today I think we should officially start our teaching of the first chapter. Okay, let me share the screen. So let me know if you can see the screen after sharing. Hold on a second. Okay, so can you see the screen? See the slides?
Yeah.
Yeah.
Okay, good. Okay, so let's start. If you have any question, I think there is some function you can raise your hand or you just post in the chat, and or after our lecture you can ask as well. Okay. Once you ask, will the subsequent chapters will be available on PDF as well? Yeah, sure, of course, yeah. But generally speaking, I will post usually chapter by chapter because I still need to modify some slides for each. So, for example, after we close to the end of the chapter 1, I will post the slide chapter 2. Okay, so as a PDF on the Blackboard. Okay. So today, let's go to the first chapter, introduction. Before we go to the next chapter, I think you have to understand a lot of basic concepts for the internet or networking, right? So we will explain what's the difference between internet and the networking. Actually, internet is one type of networking, right? Networks. So what is the internet and what is the protocol used in internet or networks, okay? And the network edge, the network core, performance, security, protocol layers, history. So I will go each by each. So some instructor may start with the history of the internet, but I think it may not be easy for you to understand before you know some basic concepts. Okay, so what is a protocol? What is the networks? Okay, so maybe we should put the history later. We should first introduce some basic concepts. Okay. So the internet, we should view internet. So before we go to the general concept of networks, let's first look at the internet because everyone is using internet every day, right? We are using the Zoom, it's based on the internet. So what is the structure of the internet, right? So if we look at the internet from nuts and bolts view, so you can see there is a billions or maybe more than billions of connected computing device to the internet, right? We have the host. So usually we call host as a end system. So you have a lot of end system, okay? And you running the network applications on the internet age. So you can see in this right-hand side figure, you have the cell phone, you have laptop, you have the server, you have the data center, right? Connect to the internet. And now I think the cars, right, can be also connect to the internet because the technology is developing so fast, right? So a lot of smart cars can be connected to the internet as well. So basically, generally speaking, within the internet, the packet will be sent and received through the internet, right? So the packet usually is a chunk of the data, right? You chunk the data into different packets and you send the data through the internet, okay? And the data packet will be go through the routers or switches. I think router and switch is not a complicated concept, right? And we have the different communication links. So we have fibers, we have copper, we have the radio, we have satellite to send and receive the data, right, through the different channels or different links. Okay, so usually different links will have the different transmission rates. So we call it bandwidth. So it's a simple concept for the transmission rate. We will define it officially later, but you will have some basic idea. Okay, so you are using the high speed, right? Networking, so you can watch video very smoothly. You can download many files very fast, right? But if you use your cell phone or Wi-Fi, maybe it's much slower than the fiber based or Ethernet based networking, right? So then this is a very important concept. So this is a networks. So even within the internet, there are multiple different networks. Later, we will give a definition of the internet. Actually, it is the networks of a network. Okay, a network of networks. Okay, sorry. So what is a networks in this figure? So you can see we have the mobile network right here. So we have some mobile networks in the left upper corner, right? So in the mobile network, you have the cell phone, you have your laptop, you have your cars, you have a different mobile system connected, right? So this is a mobile network, and we have the home network. So you have your TV, you have your I think this is a refrigerator, right? So many smart refrigerator can also be connected to your home networks. And here is an enterprise network. So what is the enterprise network? For example, different company, different universities will have their own enterprise network. So I will show a figure illustrate how a university will connect their, for example, the computing center with their different labs, computers, and different, for example, resident networks, right? So we have the enterprise network for the company and the university, for example, right? And here's most important thing, the right upper side. So this is a national global ISP. So what is ISP? Internet service provider, right? So without that, no one can access to the internet, right? So they are the central of the internet. Those they provide the service to everyone. So there is a national or global ISP, internet service provider, and we also have some local or regional ISP, right? So besides AT&T, T-Mobile, or Infinity, this global internet service provider, we also have some regional ISP. Okay, and here is some special things for modern or today's internet, because many companies like Google, Facebook, they have their own data center-based content provider network, right? They're big companies, so they have to create. So we will explain what is a content provider network. But generally speaking, they create different data centers and they put the content in the different data center. And if a user want to access the content, they will direct your request to the different data centers that will help you accelerate the speed to access the data or the content. Okay, so here is just the general structure of the internet, right? We have the different networks. So that's why we call internet as a network of networks. So they have the different networks, but they group them or aggregate them together. Okay, so is there any question with this figure? I think this is a very important start of the internet structure. So we will explain each one detailedly, but here is a bigger picture. Okay. I see one question. What about the Internet of Things? What is it related? Okay, so IoT is a concept. It's different concept with the internet, right? People are usually doing the research in IoT. Usually we use the concept IoT to refer to the, for example, the edge computing. So what is the edge computing or IoT? So they usually refer to mobile networks, this part. Okay, because I will explain more detail later. I will show you a video, but nowadays I think a lot of end device or mobile device, right, connect to the internet. How people can use such a large power of computing, right, to do many smart things. For example, everyone will have a mobile phone. The mobile will record some of your or information or intelligent data, right? So Google and Facebook, they can use that data to provide some better service, right? So usually people will use edge computing and IoT to do some thing previously cannot do, right? Just as I mentioned, they get your data, they process the data in your end, and they gather the more useful information and provide a better service to you. So this is like you process the data in the edge device. You don't want to get the data, group the data to the data center, right? So that's I think that's one of the important concepts in IoT. Okay, so another question is the interconnection through the Internet of Computing devices embedded everyday objects, enabling them to send and receive data. Okay, I think this is some official definition from the internet, right? Yeah, so this is a official definition. Yeah, but I think they emphasize the embedded and the mobile system instead of the data center or the enterprise network. So my research area is in the HPC, high performance computing or cloud computing. So we are emphasizing something in the, for example, the data center network, right? We centralized all the computing or application in the data center, and we provide a very powerful computing capability. For example, if you are training a very large model, right? So I think most of you may know something about the deep learning or something. So they are using the data center things to train the model, right? So this thing cannot be happening in the mobile system. But now many people are thinking about, okay, I have a lot of mobile phones. Can I just do some decentralized training, right? But this is a very good research topic, still in investigation. But generally speaking, people are doing the very time-consuming things in the data center, okay? But the internet, I think, is interconnection to put them together, okay? So that's, I think, interesting thing. So this is from the nuts and bolts view, okay? And what about from another view? Oh, sorry. Okay, so here is before another view. This is a interesting figure, right? It tells you what is how many internet connected device we have today, right? We have the Amazon Echo, we have the internet phone, we have security camera, we have the refrigerator, just I mentioned, right? Smart refrigerator. You have the cable TV, have a lot of things can be connected to the internet, right? So any other things here? So you can you think about any other devices connect to the internet or your smart things here? So I think many people are developing new things. As I mentioned, cars, right, could be connected to the internet as well, right? Or you have the AI device, you have virtual things. Okay. So here is another view. Oh, this video not send the both view. Sorry, I'm so hurried to to say another view, but let's finish the nuts and the bolts view. So for the structure, we know that, but before after the structure, there is still something that we need to send or receive the data between the different networks, right? So that's another important concept is protocols. So protocol is almost everywhere, right? If you want to send or receive the data, you must have the protocol. Otherwise, how would other networks know you need to send or receive the data, right? So it is a control of the sending and receiving the messages. For example, we have the HTTP for web, right? We have the streaming video, we have the Skype protocol, TCP/IP, Wi-Fi, 4G, Ethernet. We have the different protocols. So I will give the definition of what is the protocols. But generally speaking, protocol is used to control send and receive data, right? Otherwise, we don't know you want to send the data. We don't know you want to receive the data, right? So in this figure, you can see that between the enterprise network and the data center, you can have the TCP/IP. Within the enterprise network, you have the laptop to connect to the enterprise network using the Wi-Fi, right? In your home network, you can also have the Wi-Fi as well, right? And in the enterprise network, you will have the Ethernet. So I will show you a figure what is the Ethernet. But generally speaking, Ethernet is a high-speed networking connect point to point. Okay. For example, in a high-performance computing center, you need to connect the each node with each other, right? Usually we will use the Ethernet to connect point to point. Okay, so here is the HTTP, and in the global and the local regional ISP, you use the IP, and within the mobile network, you have the 4G, right? So the different networks have the different protocols. Okay, and here is something. So how people will invent or define the protocols. So there is a organization. So we usually name this Internet Engineering Task Force. Okay, so they don't define the protocols, but generally speaking, they don't impose the standards. But generally speaking, they will oversee the process by which ideas can be developed into the agreed upon the standards. Okay, so they collect the different protocols, they collect different ideas, and they just finalize which one can be defined as the protocol for the standard. Okay, so here's a nuts and bolts view of the internet. Okay, so then this is a service view of the internet. So for service, I think most of you should be familiar with what service you can get in the internet, right? So you can do the Skype, you can do the streaming video, you can do the HTTP to access the network, right? You have the different service relate to the different infrastructure, right? For example, if you want to access some video from the Google or YouTube, definitely you will access the Google data center, right? And also here's something interesting. So the the internet can also provide you a programming interface to the distributed applications. Okay, so they will hook sending and receiving app to connect to use the internet transport service. Okay, so here I want to give you an idea about, just as I mentioned, how internet would play a role as a programming interface to distributed application. So first, what is a distributed application? I'm not sure if someone in this class know the distributed networking or choose this such class, I think we have this class, right? Distributed programming design or something. So a lot of applications are distributed, okay? As I mentioned, so one very hot topic in today's machine learning or deep learning research is that is a federated learning. Is anyone here a federated learning in the past? Has anyone heard that before? Federated learning. If you heard that, you can type yes or say something. Okay, it seems no one knows federated learning, but for machine learning and deep learning, some of you should know that, right? Yeah. Okay, good. So for machine learning, deep learning, I think some of you know that, right? So you want to train a model, right, to help you recognize your voice, right? If you, for example, if you talk to uh, 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 you call some service and if you call some service now, for example, I think most of the company will have such a service, right? You have the automatic voice maybe system, right, to talk to you and direct you to the correct contact, right? So they just generally recognize your voice, right? If you need to recognize your voice or your sentence, that means you have to have the language model, right? So people are training the different model based on your voice, right, every day. So for federated learning, so I want to introduce a new concept to you. So this is a new emerging computing paradigm. Okay, so that will enable multiple end device. So for example, mobiles, for example, your laptop, for example, your smartwatch, right? To collaboratively learn a machine learning model while keeping all the training data on the edge on the device. So which means your mobile phone, just as mentioned, right? Your mobile phone connect your data, right? Connect how many, for example, how many steps you are walking every day, right? And where are you now, right? You are in a restaurant, you are in maybe a shopping mall, right? So they just collect the data, but they don't want to send the data back to the data center, right? They just use your data in your end and train the model and improve the model, right? And provide better service to you. So the internet provide a very important role in this new direction, right? So you need to send the maybe updated model to the data center, right, through the network. So this is like a distributed application. Each mobile phone plays a component in the application, right? Not just you provide the data. You also provide the computing, right, to improve the model. So I want to quickly show you a video, if possible, to give you some idea about how people are doing these things. Let me see if I can share my share my browser, but I think I also need to share my maybe share my audio. I'm not sure. Let's see. So here my browser, but does anyone know how to enable the audio sharing?
Yeah, I believe under your share screen there should be.
Oh, okay. I see that. I see that. The share computer sound, right?
Yeah.
Okay, that's good. Thank you so much. So let
Yep.
me. Okay, so let me try to play the video. So if you can hear the voice, the audio, just let me know. Oops. Can you hear the voice? Audio? I cannot see that. No, right?
No.
Uh, okay, maybe I don't know. Maybe I have to restart the Zoom. I don't think so.
Can you
Try
hear
just putting
on your end?
subtitles on the doesn't make.
Possible the video audio needs to be turned up.
Yes, I can see the small box to share the computer sound, but my point is that maybe my desktop prevent that. I need to restart the Zoom. And because I'm recording, maybe I will play this video later. Okay, so I don't want to quit the Zoom and re-enter. That's cut off the video recording. But this video just give us a general idea how people are using cell phone, right? And give your data and then every cell phone will send the data, right? Or improve the model to the final model, right? So every mobile will play a very important role to improve the final smart or intelligent model, okay? So this is a video from Google. So they're doing the federated learning things, trying to leverage the very powerful computing capability of each cell phone, right? Because we have billions of cell phone, right? So they just try to, okay, they just try to leverage this capability. So let me go back to the PowerPoint. Okay, so I will try to fix the problem and maybe next time let's try to connect another video. Okay, so but the concept, I think, generally speaking, is very interesting, right? You are trying to leverage everyone's cell phone, everyone's and device, right, mobile device, to aggregate the computing power, right, to improve the model. Okay, yes. Federation, a group of states with a central government but independence in internal affairs. Yes. Right, that's a similar concept, right? Yeah, so they just to federate something together. Okay, so my point here is that that's some machine learning or deep learning research direction. But my point here is that without the internet, you cannot achieve that, right? So internet as provides a programming interface, right? Every mobile connect to the internet, and you can use the internet to send and receive some part of the information from the distributed applications, right? And you can program as every cell phone as your component, right? To leverage the internet sending and receiving data, okay? So I think that's why today a lot of research are coupled together. You cannot just say, okay, I'm doing the machine learning. I'm just using my laptop or desktop to do the training. That's not possible, right? Data is like a flood, right? So you have a lot of data that you can use. If you use more data, you can provide more powerful model. You can provide better service. So giant company are trying to leverage networking and the device IoT, HPC cloud, everything together, right, to provide you better service. So you can see many things are coupled together and they're not independent. Okay, so next thing, what is a protocol? Okay, so human has a protocol, right? So you ask people, what is time? Then people will give you the time, right? So you say, I have a question. People will say, what is the question, right? Human has a protocol, right? You give an introduction, people will give you some feedback. So it's the same thing, right? The network, the different device, if they want to send and receive data, they must have the protocol, right? So computers, devices, rather than humans, they also need to have the protocols. All communication activity in internet are governed by the protocols. Without protocol, you cannot do anything in the internet, right? So protocol define the format, order of messages sent and received among network entities and actions taken on message transmission received. Okay, that's a definition. So let's see what is a protocol. Just as I mentioned, what is a protocol in human and in a network or machine or device, right? So people will say hi, you will say hi, and then what is the time, and you got the time, right? So a lot of other protocols, right? Say hi and say hi, and you say you just I have a question. People will say, what is the question? And then you will give the question. People will give an answer, right? That's the general protocol. And what is the protocol in the internet, right? For example, this is the TCP protocol. The TCP connection just send a request, and then another end system will send back the TCP connection response. Because first they want to establish the connection, right? Because you say hi to someone, some people will say hi back, right? So you can see two different people, right? So here is a TCP connection send and TCP connection response. And after that, you establish the connection, right? And then you say, okay, I will get the web page, or I want to get access to this web page. And then you will get the file or web page from that server, right? So this is network protocol, right? It's very similar to humans protocol, but they must have the standard, right? How to define the different protocol between the different networks, between the different systems, okay? So here is just a general idea about what is internet, what is a protocol, okay? And then let's go to the network edge, host, how to access network and the physical medium to transfer the data, right? From the top to down. Let's look at the internet structure closer. Okay, as we mentioned, we have the different network, mobile network, home network, enterprise network, regional ISP, global ISP, content provider network, data center, right, in data center. So here's this is a figure we will we will use for multiple times in the future, right? So you should be familiar with this picture. And for the network edge, so generally speaking, we will have the clients and the servers for the host, right? So client and server, that's a very, commonly seen concept, right? So for the data center, definitely there's a server, right? You want to access the data, you need to get to the server, right? But the client, almost everything you are using is a client, right? I say generally speaking, right? So because you are not a server provider, right? I have some server. I provide the server to the student to do the HPC application or programming or development, right? So I have a server, but generally speaking, server is very expensive, right? So if you don't want to do any business, if you don't to provide service, you don't need to have the server, right? And also server need to be established in some dedicated space. It needs to be running almost 24/7, right? Because if you shut down the server, people cannot access to your service. So generally speaking, server will be provided in the data center or maybe in HPC center, a cloud center, whatever center, right? And the end device is a client. Okay, and how you can access to the networks. So what is the physical medium? So you have the wired, you have the wireless communication, you have a wired communication links, right? Everyone knows wired and the wireless communication. You have Wi-Fi, right? You have the 4G, right? Cellular network, right? You don't need to wire them together. So so here's a different method to access the network. Okay, and the network core is interconnected routers with different components to the local regional ISP provider, right? An internet service provider ISP. Okay, so as I mentioned, the internet is a network of networks. So it have different components. Each component is also a network. So we will give a introduction to each categories. Okay, so what is detail about network edge, detail about the how to access the network, wire or wireless, and the network call. So first question is how to connect the end system to edge router. You have a lot of end system, right? Laptop, desktop, refrigerator, smart refrigerator, cars, a lot of things. How you connect them? Just I mentioned. So you have the residential access net, you have the institutional access networks, you have mobile access networks, right? We have already introduced that. And different network have a different method to connect to the internet, right? Because for example, you don't want our university's labs desktop to use Wi-Fi connect to the internet, right? Because they're always sitting there, right? They have to provide a very stable connection, right? Bandwidth. So definitely you don't want to connect the lab's desktop using the Wi-Fi, right? But you can, my point is it's not good, it's not the optimal solution. But for your laptop, you don't want to use wired connection links, right? Because you want to move laptop everywhere you want to go, but if you use a wire, you cannot do any move, right? So each device should have its not optimal, but preferred access or connect approach, right? And it also a consideration, there is another consideration is the transmission rate, right? Just I mentioned, if you have the desktop, you want the transmission rate to be as high as possible, right? You want to download a lot of data, you want to do the maybe upload the data or upload the video, whatever. So you just want to have a wired connection, right? So the transmission rate is also a consideration. And then the problem is that how we can do the access using the shared or dedicated access among the users, right? So we will introduce that later. So here is the first thing. So how you will access the networks using through the different networks. This is first is the home network. How you connect, how you access the networks in at your home. That's the first question, right? So I'm not sure if you establish your network by yourself when you maybe so for example, when I was a graduate student, I rent a apartment, right? When I move into the apartment, I don't have any internet service. I have to establish the internet service by myself, right? So the question is that how the internet service provider connect your home to the internet or the global regional ISP, right? So I guess some of you may know that if you want to get the internet, you should call the different provider, AT&T, right? Or Xfinity or Comcast. Comcast, I think Xfinity is the same company, right? So you call the different provider, but the different provider actually have the different method to make you access the internet, okay, through the different communication links. So here, first is a cable, right? So some of you may have the cable in your home, at your home, right? You can watch TV, you can access the internet, but the cool idea is that they are not using the separate link. They're using the same link, right? So that's why you usually hear providers, internet providers advertisements saying that, okay, do you want to open the TV or you just want to the internet, right? Because they can be combined together. Okay, if you request the internet, they just give you internet. If you want to have the cable or TV, they can also give that to you, because they share the same link, but the same link has a different channel to transmit the different frequency bands with the data. Okay, so that means if you want to use the internet digital data, they have the different frequency with your cables, UTV's data, right? They share the same link, but they have the different channels, okay? Data for the TV, audio, video for the TV through this channel, your internet data through that channel. They share the same physical links, right? So we call it a frequency division multiplexing, okay, FDM. Different channels transmit in the different frequency bands, okay? But they finally or eventually will connect to the central office of the internet provider. Okay, so they are hybrid, right? Hybrid fiber coax. So that you can see data, TV transmit at a different frequency over the shared cable distribution network. They are using the same link, okay, but they are based on the different frequency. And because of the hybrid feature, and they are shared together, share the same link, the download, and usually we call it download or upload, right? But also it's downstream and upstream, right? Transmission rate are usually not the same. They are kind of the asymmetric, okay? So for example, for the downstream, usually it will have a 40 megabits to 1.2 gigabits per second. Okay, here pay attention that this Mbps is a megabits per second. GBS is a gigabits per second. Okay, so if you have some basic understanding of bits and bytes, right, they are not the same. So if you want to download the 100 megabytes data, right, so it's almost equal to 800 megabit, right? So you can calculate, generally speaking, you can calculate some rough number or second you need to transfer that data, right? So that's another reason. I'm not sure if you have the observation, right? If you want to upload the data and if you want to download the data, sometimes they are not as fast as not the same speed, right? So if you want to download data, sometimes it's faster, a slight faster than you upload the data, right? That's a reason, right? And the network of the cable fiber connects the home to the ISP router, right? To the service provider. Okay. So here's the first thing. Another approach. So I remember when I was a child, I was not using the fiber or cable thing, right? I'm using the telephone line, right? I use a telephone line. So that's much slower than the current internet. But the thing that at that time, a telephone line can also provide a service to internet, right? So the data of the DSL, so DSL is a digital subscriber line, okay? The short for this digital subscriber line, okay? So the data through the DSL phone line goes to the internet, voice through the DSL phone line goes to the telephone net. They have the different dedicated line, okay, connect to the central office of the telephone company. So you can see the number for the upper stream and downstream transmission rate. They're much smaller than the fiber coax one, right? So, but that's a history, right? So our internet developed from this part to the current one. So we have a fast internet connection, but many years ago, we are using the telephone service to transfer the data for both your telephone voice and the digital data, okay? So general speaking, so here are the home networks. There is a modem to connect your home to the, it could be cable or could be DSL modem, connect your home network to the central office, right? And then you have the router, you have the firewall, you have NAT, and then you have your wired Ethernet links to connect your desktop or laptop, right? If you prefer to use a wired in your home, you can use that. And then you will have a Wi-Fi, right, to connect your cell phone, okay? And then but generally speaking, now if you want to establish internet service, the provider, for example, ATT will ship you one box, right? That box will contain the modem, contain the Wi-Fi, contains the router, everything together, because that's easy for you to use, right? You don't need to have separate devices. Okay, so what is the difference between modem and the router? I think a modem is something, right, to explain the data from the central office, but router is just to route your data to the different IP address, to the different destination. So we will give a definition of what is a router and what is a routing algorithm. So there is some algorithm, right? Yeah, through the network, you must know how you can send the data to the destination. But there is some different algorithm, right? The optimal algorithm can give you the faster transmission speed, right? But if your routing algorithm is bad, that means you cannot find the correct path to the destination, okay? So that's the concept we will introduce. But generally speaking, modem just to explain the data you receive, and then router just to send the data to the destination. Okay, so I can quickly finish the wireless access network today. So for wireless network, I think everyone should know that you have a Wi-Fi, right? So and for the Wi-Fi, usually speed is good nowadays, right? It's not. I don't want to say it's much slower than the wired wide one, because at home you just use 1 gigabits, maybe Ethernet for wide thing. But for Wi-Fi, you can see now we can have the 450 megabits. So just maybe half, but it's not much slower, okay? But it's much easier, right? You don't need to take the wire everywhere. And also it have a wide area cellular access network, right? As your phone. So for these two different wireless access, they have the different coverage range. For example, the Wi-Fi, it can cover almost 100 feet, right? Or maybe more than or 150 feet. But for the your cellular access network, right? You have 4G. Previously we have 3G, now we have 4G, but later we will have 5G and we will have 6G, right? So for example, 4G network, it generally speaking, it can cover 10 kilometers, okay? And with the transmission rate about 10 megabits per second. It's just slower, or it's lower than the Wi-Fi, but you can see the coverage range is much larger, right? The problem for the 4G, 5G, 6G is that they are more and more powerful, but the coverage range could be a problem. So they could be, coverage range could be smaller and smaller, but the data transmission rate would be larger and larger. Okay, then the problem is that how the internet service provider will set up their station, right? So this is something we will discuss later, but generally speaking, you will have a higher transmission rate, but a lower coverage range, right? So this is a wireless access network, okay? So we will talk about enterprise network in the next lecture, and I will also show you how university network connected to the internet and what is the internal network structure. Okay, so this is today's lecture. Any question? So we can have 1 or 2 minutes to discuss question. So if you have, or we can do that in the office hour as well.
Just a quick question. So,
Okay.
This is regarding the whole chapters thing that I'd mentioned earlier.
Mm-hmm.
So those chapters are coming out of the main textbook, the main required textbook, correct, in PDF format?
Yes.
Okay, good, because I'd rather not purchase that if I have the option to conveniently have all the chapter PDF form. Thank you.
Okay. Yeah. Yes. Yes. Yeah. It's mainly from the PDF of the textbook, and sometimes I cut something, sometimes I add something. For example, I add the university internet network connectivity, right? So I want to give you some idea how WSU, how all my previous institution, how they connect the different device to the enterprise networking, and finally go to the internet, right? I will add something, but generally speaking, they are based on the PDF of the textbook. So don't worry, if you don't have the textbook, I think that should be fine.
Thanks for the info.
Mm-hmm. Yeah, any other question?
I have a quick question about sort of content on exams. So it seems like you're throwing a lot of terminology at us, and that might just be because it's first couple days. But is that where we should pay really close attention to the exact terminology used, and we should know exactly what frequency division multiplex is, and like those terms are really key, or is it more getting across the concepts that's the big takeaway here?
Oh, good question. Okay, so for example, I think the the concept as I mentioned here, right? So the so frequency division multiplexing or something here, I think that's a high level concept, right? You don't need to know this very deeply, but for example, the later we have the latency, we have the loss, we have the bandwidth. That's a very key concepts, and we will have some question or examples to give you that how can you can calculate the latency, how can you calculate loss or throughput, bandwidth, something like that. That concept are very important. You should know, and you should know how to do the question and answers or the exams. You should expect something in the exam using that concept. But for this high level things, I don't think you need to expect a question in the exams.
That helps a lot. Thanks.
Mm-hmm.
I have a question.
Mm-hmm.
Will you be giving a lot like a exam study guide or something to get us a little bit on kind of what the content you're expecting us to know?
Sorry, I was a little bit cut off. Can you repeat your question?
Yeah, I'm just wondering if you're gonna be giving a study guide or like to kind of guide on the concepts that we should know.
Yes, I think so. Yes, I think especially for the first chapter, right? A lot of concept would be introduced, and then I will give a summary of what kind of the concept is the key or core for the first chapter, especially for the first chapter, and we can do a summary. Yes, and also my point is that we will give some example question or assignments, right? The assignment will cover some concept. That concept or those concepts should be the key concepts in your exam. Okay. For example, I don't want you to write the definition of the frequency division multiplexing in the homework or assignment. That means this concept is not the key or part. Okay.
Awesome. Thank you.
Mm-hmm. Okay. So if no questions, so let's end here. So for your information, the TA may not be available for the first week, but he will be available from next week. And for the first week, I think most of things are concepts without any question. But if you have anything, you can go to my office hour. I will post the announcement for the office hour right now. Okay, so but just for information, the TA will be online from next week. Yeah. Okay, so thank you everyone. Let's see on Friday. Okay, have a good day.
Thank you.
Mm-hmm.